Welcome to Mastering Solutions. As we draw a picture of what's happening in this question, we tell us that we have some water here and a laser beam is coming in like this, okay? And then we can say that here is the normal, and then it's getting refracted at some angle. And what are those angles? So they tell us that the laser beam is incident on a liquid at an angle of 37 degrees with respect to the normal. So that means from the normal out, that angle is 37 degrees. This angle right here, the laser beam in the liquid is 26 degrees. So that's 26. And so, of course, we're going to be using Snell's law here. So let's write the equation for Snell's law. We know that n1 sine theta 1 is equal to n2 sine of theta 2. So what is our n1? Well, we're in air, so that's going to be 1. And our n2 is something. We don't know what this is. This is what we're trying to solve for. I think I said earlier in the question that this is water, but we don't know what this liquid is. It's some sort of liquid, and that is what we're trying to find. And so if we rearrange the equation, let's isolate n2. So to do that, we can simply divide both sides by sine of theta 2. So n2 is equal to n1 sine of theta 1 divided by sine theta 2. So we have all the values here. We know that this is 1 for air. So really what it is we could simplify it for this question one step further and say n2 is equal to sine of theta 1 divided by sine of theta 2. And so when we plug in our numbers here, we have n2 will be equal to sine of theta 1, which we said was 37 degrees, divided by sine in the liquid, which we said was 26 degrees. So when we plug that in, we have sine of 37 divided by sine of 26. And that's equal to 1.37. So we could round that to 1.4. So n2 is 1.37, which rounds to an n of 1.4. So using Snell's law, we found the index of refraction for this liquid is 1.4.